In this video, we're going to go over the answers to Balancing Chemical Equations Part 1. You can open this video in one tab and your worksheet in the other tab so that you can correct your answers as we work. The first step is to watch the screencast that Mrs. Clymer made diagramming the Chemical Equations Part 1. What notes did you write in the space below, Angelina?
Okay, so in the space below, I wrote that both sides of the chemical equation, on both sides of the arrow, need to have the same number of atoms in it.
Very
Yeah.
good. What did you write for number 2 after you watched the video?
So the reactions that I saw demonstrated in the video that I watched were bubbles were formed, and there was heat formed, and also there was gas.
That's correct. In the first chemical reaction, potassium and chlorine react to form potassium chloride. And your first step was to model the reaction. So we're going to make a potassium chlorine molecule and a potassium chloride molecule on the right-hand side. Now everything on this side of the arrow has to match everything on this side of the arrow. Now that we modeled it, Angelina, can you tell if both sides match?
I would have to say no, because there's 2 chlorine atoms on the left and only 1 on the right.
That's right.
So
So we're going to add another chlorine, but you can't just add it by itself. It has to be attached to a potassium because that's what it shows in the chemical formula here.
and then you'd have to add another potassium, because then
Where
there's
should
2
I add it, here or here?
on the left.
Very good. All right.
That looks pretty good to me.
Very good. Now we're going to add the coefficients. So what number should I put in front of the potassium here? You have to count the number down here to know it to go here.
There's 2 potassium,
Right.
so I would have to say 2.
Okay. Now be careful on this one. How many chlorine molecules? Not atoms, but molecules.
That one's tricky.
Mm-hmm.
I would say 1.
You're correct. All right. And finally, how many potassium chloride molecules?
2.
2 is right. Okay, everybody, check your answers and correct your papers before we go on.
Gee, science sure is fun.
Yes, it is, isn't it, Angelina? Equation is the reaction of sodium chloride and fluorine to make 2 new products, sodium fluoride and chlorine. First, we model sodium chloride, and then we model the fluorine. Now, fluorine is a diatomic element, so we have to put the 2 fluorines connected together. Don't put them like this. They have to be connected together to show the chemical bond. And then sodium fluoride looks like this, connected together, like that. And then chlorine is another diatomic element, so it needs 2 according to the chemical formula. Oops, kind of flattened it there. All right, now, Angelina, do both sides match? It might help if I draw the line for you. Hold on, let me draw the line. All right, you have to look on both sides of the line.
No, they don't match, because the right has 1 more chloride and 1 less, what is that, fluorine.
Okay, so if the right has 1 more chloride, then we need to put another one on the left,
Yeah,
right?
but you'd have to add a sodium with it, because they're connected.
Very good. So let's put a sodium. We'll put a sodium here.
And then you'd have to add another sodium fluoride.
Fluoride.
Fluoride. Oh yeah, to the right. Yeah, right there.
Okay. Is it balanced now?
Let me see. 2, 2. Yes.
Okay, time to add the coefficients in.
So that's a 2. And then a 1, because it's one of the double guys.
That's right. You have to see what the formula says. We're looking for how many F2s there are, and there's one F2, one fluoride.
And then it's 2.
2 is correct.
And then it's 1.
Okay, everybody, check your answers. Did you get this one right? Angelina did. Now we're going to try the last one. The reaction of iron and chlorine to get iron chloride. Let's start with our model. There's the iron. There's the chlorine. Now this one's kind of funny because you need 3 chlorines on it. Takes up a lot of space, but we can just keep dragging them there. 1, 2, and we need 1 more, 3. All right, there's our iron chloride. I'm going to draw a line down the middle to separate the 2 sides. So Angelina, you got to make sure that there's the same on both sides.
Okay. So you would have to add another chloride to the left.
Chlorine molecule?
Yeah, or chlorine. Wait, is it called chloride?
It's called chlorine molecule.
Oh, chlorine molecule.
On this side, it's called chloride because it's part of an ionic bond.
Gotcha. All right. So then it's still not right. Well, the next step I would say would be add a chloride
Over
on
here?
the right. Yeah.
You can't just add a chloride. What do we have to add?
With the iron.
Right, iron chloride. So I need 3 of these guys. That gives us 6 chlorines now over here.
And then I would add another of the, yeah, what are this called again?
Chlorine.
Chlorines.
Chlorine gas. This is what chlorine gas would look like.
And then lastly, I would add another iron on the left.
You did it.
Yeah.
Now let's just double check. 2 iron on the left and 2 iron on the right. 6 chlorine atoms on the left and 6 chlorine atoms on the right. So let's put in our coefficients.
2.
A 2. Careful on this next one.
A 3.
3. 3 groups of Cl2.
And a 2.
You got it. Now let's check your answers to your questions, Angelina. Why are there always the same number of each type of atom on either side of a balanced chemical equation? Relate your answer to the law of conservation of mass.
So the law of conservation of mass says that matter cannot be destroyed or created. So that would be my answer.
Okay, so we have to end up with the same number of atoms after the reaction.
Yeah, you can't just pull new ones out of the sky. Like, they have to come from somewhere.
Correct. Okay, how about number 2? What is the difference between a coefficient and a subscript in a chemical equation?
Well, they're both numbers, but the coefficient is the one that it basically is saying how many of each of the molecules there are, and then the subscript says how many of the atoms are in that molecule. So,
Awesome job, Angelina.
thanks.
Thanks for helping out today.
No problem.